Hello developers, parts 1 and 2 of this series covered the runtime, memory management, property, atomic, protocols, and the singleton. If you have not watched those, go back. The links are in the description. This builds on all of it. This is part 3. And the questions in this video live at the intersection of Objective-C and UIKit, the place where most production iOS apps actually spend most of their time. Because knowing the language is not enough. Interviewers at companies with real UIKit codebases want to know if you understand how the UI layer was designed to work. KVC, IBOutlet, IBAction, IBDesignable, storyboards, XCB files, MVC, and the responder chain. These are not questions about syntax. They are questions about how the framework thinks. Understanding how UIKit thinks is what makes you dangerous in a legacy codebase in 2026. Subscribe if you are serious about iOS engineering at a senior level. Let us get into it. The questions in parts 1 and 2 were mostly about the language. The questions in this video are about the framework. UIKit was designed in Objective-C, around Objective-C patterns, and many of those patterns are still in the UIKit API in 2026, even in Swift projects. When an interviewer asks you about KVC or IBDesignable or MVC, they are not testing whether you have memorized definitions. They are testing whether you understand the design decisions that shaped every UIKit app ever shipped. That is the frame for every question in this video. Question 1. How does KVC work in Objective-C? Key value coding, KVC, is a mechanism that lets you access an object's properties using string keys instead of direct method calls. Instead of calling self.name, you call. The runtime resolves the string to the actual property and returns its value. Direct access is compile time and type safe. KVC is runtime and string-based. You can set values using setValueForKey and traverse object graphs using key paths. Collection operators like @avg and @sum allow you to perform calculations across arrays of objects directly through KVC key paths. The runtime follows a defined lookup order. It first looks for a getter method matching the key. If it does not find one, it looks for the backing IVAR directly, like _name. If none exist, it calls valueForUndefinedKey. That is why KVC is powerful, but also dangerous. A typo in a string key is not caught by the compiler. You find out at runtime. Question 2. Why does KVC still matter in 2026? 3 reasons. First, KVO is built on top of KVC. The key paths you pass to KVO observers are KVC key paths. Understanding KVC explains why KVO crashes when you pass a key path that does not exist. Second, core data uses KVC internally. When you call valueForKey on an NS-managed object, you are using the same mechanism. Third, Storyboard and zip file loading uses KVC to set IBInspectable property values at runtime. The connection between Interface Builder's attribute inspector and your code goes through KVC. IBOutlet is a keyword that marks a property, so Xcode knows it can be connected to a UI element in a Storyboard or XIB file. When you drag from Interface Builder to your code, Xcode writes an IBOutlet property declaration. At runtime, when the Storyboard or zip file loads, UIKit uses KVC to connect the outlet. It calls setValueForKey on the viewController, passing the instantiated UI element as the value and the outlet property name as the key. Question 3. Why is IBOut? Let almost always declared weak. Because the view hierarchy already holds a strong reference to every subview. A UI button on screen is strongly retained by its superview. If your outlet is also strong, you have 2 strong paths. When the view is removed, the superview releases its reference, but yours does not. The button leaks until the viewController deallocates. In Swift, the weak recommendation is identical. The only exception is top-level SIB objects not in the view hierarchy. Since nothing else retains them, they must be strong. Question 4. What is IBAction, and what does Interface Builder actually generate? IBAction is a return type keyword. It maps to void at compile time. That marks a method as connectable to a UI event in Interface Builder. Xcode writes an IBAction method when you connect an action. There are 4 valid signatures, with or without sender and event. IBAction and IBOutlet are macros expanding to hints for interface builder, not Objective-C runtime features. Removing the keyword does not break the runtime connection, but it removes the metadata interface builder uses to show that method as connectable. A less-known feature. If you set the target to nil, UIKit walks the responder chain looking for the first object that responds to the selector. This decouples the view from a specific controller. This is what makes first responder management critical for keyboard handling in complex forms. Question 5. How do IBDesignable and IBInspectable work under the hood? IBDesignable marks a custom UIView subclass for live rendering in Interface Builder. Xcode builds your class in a separate agent process and calls drawRect and prepare for Interface Builder to render a live preview. IBInspectable marks properties for the attributes inspector. The values are set through KVC. Failure modes include silent crashes in the agent process or using unsupported types that Xcode ignores without warning. Debugging IBDesignable requires checking agent logs in the report navigator. Also, remember that IBInspectable only supports a limited set of types like bool, CGFloat, and UI color. The questions in the first half of this video, KVC, IBOutlet, IBAction, IBDesignable, are all connected by the same thread. They are all mechanisms the UIKit team built to make Interface Builder work. KVC powers outlet connections. IBAction is a hint to the IB parser. Understanding how Interface Builder actually works, under the hood, is what separates an engineer who can debug a UIKit app from one who can only build one. 4 more questions. The second half is where the architecture conversations happen. Question 6. What is the difference between storyboards and zibs? Both storyboards and zib files describe a UI. The difference is scope, ownership, and reuse. A storyboard contains multiple view controllers and the segues between them. It owns the flow. A zib, or nib, describes a single view or controller in isolation. It is a reusable component. You choose a zib when you have a view like a custom cell or card that appears in multiple contexts. You can instantiate controllers from storyboards by identifier, or load views from a bundle using loadNib named. Registering zibs with table views is a common production pattern even in 2026. Question 7. What is MVC in UIKit, and why does Massive View Controller happen? UIKit was built around Model View Controller. The model owns data and business logic. The view owns visual presentation. The controller, UIViewController, is the coordinator binding them together. The model knows nothing about display. The view communicates user interactions upward through delegation. The controller reacts to input and reflects model changes back in the view. Where do most teams get it wrong? The view controller becomes a dumping ground for networking, parsing, and business rules. The result is Massive View Controller, a single file that does everything. The answer that lands is recognizing where it breaks. MVVM, Viper, and TCA exist as responses to this problem. The interviewer wants to know if you have thought carefully about how to prevent it. Question 8. How does the responder chain and the full UIViewController lifecycle work? The responder chain is UIKit's mechanism for delivering events. Every object that handles events inherits from UIResponder. When an event occurs, UIKit finds the first responder and asks it to handle it. If the first responder cannot handle it, the event travels up through the superview chain, the view controller, the window, and finally to the application delegate. Overriding touches, Began lets you intercept these at any level. If you set an action target to nil, UIKit walks the responder chain looking for the first object responding to the selector. This is what makes first responder management critical for keyboard handling in complex forms. Most developers know the method names, but fewer know exactly what state the view is in at each call, or where the bugs live. Let us walk through the timeline from init to dealloc. In init, the object exists, but the view hierarchy may not be loaded yet. Never assume outlets are ready here. If the view or view controller comes from a storyboard or zib, UIKit unarchives it first. Then awakeFromNib is called. AwakeFromNib means the object has been loaded from the nib or storyboard archive, and its outlet connections have been restored. This is useful for setup that depends on interface builder connections, but it should still stay lightweight. Override load view only for fully programmatic UI. In viewDidLoad, the viewController's main view exists and is loaded into memory, but it is not on screen yet. This is where most one-time viewController setup belongs. ViewWillAppear runs every time the view is about to come on screen. Use it for lightweight updates that must happen before the user sees the screen. Then, viewIsAppearing runs, while the view is being added to the hierarchy and the appearance transition is in progress. This is useful for layout-sensitive work because the viewController is now participating in the appearance cycle, but the transition has not fully completed yet. ViewDidAppear runs after the view is fully visible. This is where you start animations, video playback, analytics tracking, or work that should only begin once the screen is actually on screen. ViewWillDisappear runs when the view is about to leave the screen. This is where you pause timers, resign first responder, cancel in-flight UI work, and prepare the screen to stop being visible. ViewDidDisappear runs after the view is gone. This is where you stop background tasks like video playback, remove temporary UI state, or clean up work tied to that screen being visible. Finally, dealloc is where you remove remaining observers and release anything that should not survive the controller. Common bugs include accessing outlets too early, confusing awakeFromNib with viewDidLoad, starting network calls in viewWillAppear without cancellation, doing layout-sensitive work too early, and adding observers in viewDidLoad but removing them in viewDidDisappear. And the most silent killer, forgetting to call super. It breaks every subclass and leaves the framework in an inconsistent state. Always call super in lifecycle methods. 8 questions. KVC, IBOutlet, IBAction, IBDesignable, storyboards versus zibs, MVC, the responder chain, and the full lifecycle. The thread is clear. UIKit was designed around Objective-C patterns. Understanding these patterns is what makes you the engineer who can debug the problems nobody else can explain. If this series helped, subscribe, like the video, and leave a comment with your favorite question. And if you need senior-level guidance to scale your app, visit tonytrejo.com and let's talk. I will see you in the next one.